less costly, and a process that is more effective has driven the demand and a change of the documentation and the design process of construction. And this is where building information modeling comes into play. So, so what is BIM? In order to understand BIM, we must first understand that BIM is a very popular buzzword between software developers who try to describe their software and BIM as new capabilities to their software. So therefore, it leads to a lot of confusion and variation into what BIM is. And to first understand what BIM is, it is most important to understand first what BIM is not. So what is not BIM? BIM is not a single building model or a single database. It is actually better to describe BIM as a series of interconnected models and databases that can then be shared globally. It is also not just a piece of software. Rivet and ArchiCAD or Bentley, they're all applications to BIM, but BIM is not just these softwares. BIM is also not just 3D. 3D is a very important part of BIM, but it doesn't compromise what BIM is. When you have a 3D model, you still have to interpret what it means, you have to share it, and you have to compare it with other things. So this is what BIM does. And BIM actually doesn't even have to be 3D. For example, we have the simple spreadsheet. The spreadsheet has the name, the address, the city, the state, and the zip code. It's in standardized format, and it's a very useful tool, but it's not yet BIM. So then, when we put this information into Google Earth, each line of information is analyzed and placed into context. Now this information has grown in dimension and power, and it can now be used and shared with other comparisons, and so therefore now it is input into a bigger database, and now it can be used in comparison, and now now you can call it BIM. So now, after we understand what BIM is not, we can go ahead and say what is BIM. So BIM is a new approach to design and documentation. In the building aspect of things, the entire life cycle of the building is considered. In the information, BIM actually helps to store all this information, which can then be shared, and modeling through the simulation of models, which can then be shared, and data can then be reused and used again. BIM describes an activity. BIM is used as an adjective or a verb to describe tools, technologies, and processes that can then be this tools, technologies, and processes that are facilitated by digital documentation about a building, its performance, its maintenance, and its operation. Therefore, BIM describes an activity and not actually an object. There are 5 principles that can be used also to describe what BIM is. In the communication aspect, in the communication principle, this technology is used to give immediate access to any information needed. In the integration, BIM optimizes working practices, methods, and information and integrates them to complete one whole big database. And the interoperability of aspect, BIM builds structures that capture absolutely everything. This information can then be shared, and repetition is eliminated, meaning work is done only once, and the information can then be used for many purposes. In the knowledge aspect, BIM captures everything in dependable archives. So these are storage units such as products or anything that you can access at any time that is needed. And then certainty, BIM is used to make things clear. It allows for the reuse of data to get to the right information at the right time for whoever who needs it. So there's a history of BIM. There's the old trends and the new trends. With the old trends, way before BIM, there was the start of design documentation. This is when people wanted to communicate a 3D world, the reality, into a 2D documentational communication platform. So this 2D communicational platform consisted of the usual elevation plans, the sectional views, and the details. And this actually was the first time that a universal language for 2D was used and was able to be shared among everybody. The traditional processes before BIM were the mechanical methods, meaning the pen, the paper, the ink. These processes were then put into a computing process, and that's where CAD came along. So CAD was basically you put all these, now instead of doing it by hand, it's done in the computer. So you get the same results, but at the same time, you're having the production is affected greatly. So more better details and better details and faster production of these drawings were actually made. Then these CAD models were built into 3D CAD models. The current and then there's the current trends, which can be divided into two types: the process trends and the technology trends. So the current process trends is a growing demand for BIM. Owners are now demanding BIM. More and more owners are now demanding BIM, and they're even using user guidelines to make sure that BIM is incorporated into all the projects. The demand for people with new skills is also growing, and even new management roles are being created, such as the BIM specialist, BIM engineer. And since BIM has had such a great success over the years, there has been a corporate BIM uptake throughout companies nationwide. Current technology trends, vendors are actually expanding their scope, meaning they're adding more applications and you can do more things with BIM. 3D catalogs are being made, meaning this refers to any products such as the reverse slicers or windows that can now be accessed through BIM by the fabricators or designers installing these products into the archives of BIM. BIM tools are also being created. More BIM tools are also being created to facilitate the process of creating these documentation and design processes. This is actually a picture of a BIM tool. It shows a component-based simulation that allows healthcare owners and designers to compare different configurations with different equipment. So this is another BIM tool that is being used. So with any growing technology, BIM has some disadvantages, but it also has a lot of benefits. First, let's talk about the disadvantages. The disadvantages of BIM are errors in accuracy. Whoever puts information into BIM, we're all humans, and as humans, we can make mistakes. So if whoever is putting this information into BIM can easily make a mistake, and since the model is such a big component in the core project of the construction process, these errors can actually, if not detected early, can be passed down through the process. Changes happen easily. BIM is a very easy technology. Well, not easy technology, but people can make changes to it easily. Such as owners might decide to want different things later in the process, and therefore it can ultimately affect it can ultimately impact the cost and the design and the process. BIM is also very costly, meaning new hardware, new upgrades, new computer software, and even teaching people. And companies have to teach their employees how to use this. It's becoming very costly. It requires more thoughtful decisions, meaning now whoever is using this BIM tool has to think as the previous good designers have used, and this is like you have to visualize in 3D. Visualizing in 3D is not sometimes so easy to do. And there's also many legal concerns, such as who might own the multiple design, the fabrication, the analysis, and the construction databases, who pays for them, and who can be responsible for the accuracy. Despite these disadvantages, there are also many benefits that BIM can offer. BIM can reduce risk through simulation of models. You can detect errors early and before any construction is actually made, and also through cost estimation. It manages change. It allows for fewer change orders, fewer mistakes, and fewer losses. It creates clarity. It improves profitability, BIM helps to create more accurate cost estimates at earlier stages. Data has actually showed that new projects save 8 to 15% in savings. It improves communication between owners, designers, and engineers if used right. It increases efficiency, and it increases sustainability through the use of energy analysis. The applications of BIM. There are many applications of BIM, but I decided to kind of just divide them into each stage of the construction process. So here we have pre-construction, design, construction and fabrication, post-construction, and green building. And the handout I actually gave you guys, it describes further into detail these applications and their benefits, and even it relates to even case studies that you guys can also search and read up on if you wanna get to know these projects even more. So in pre-construction, BIM helps to increase building performance. This is done through BIM being used as an analysis and simulation tool. It reduces financial risk through a cost estimation tools. It assures project schedules. It assures program compliance, meaning it is a constant, and BIM can be used as a constant analysis of between the building and what the owner and what the local requirements actually are. And it can optimize facility management and maintenance. In the design phase, BIM can help in the conceptual design. The conceptual design is the actual concept of the project as well as the spatial relation. So through the simulation of the model, you can have designers and contractors can have a better understanding of what goes where. So there's a better use of space. Integration of engineering services and construction level modeling, meaning through the simulations of the models, you can have better drawings and better understanding of what goes where. This is actually an example of a specialized drawing this is an example of a concept design. Here you can see the spaces of each level and how they are related to each other through it's either a horizontal circulation or vertical circulation, and each zone is divided into 3 areas as well. BIM can also help in construction and fabrication. This is through the use of class detection tools, quantity takeoff and cost estimating, construction analysis, through the incorporation of BIM components and construction method information, including spatial, resource utilization, and productivity information. The 4D CAD also comes into play when you have construction analysis. BIM can also be used in the integration of management functions, like meaning designers and engineers can come together and figure out integrate their ideas and have a better process and a better project at the end. It can help in the use of offsite fabrication. Designers can directly input what they want, such as products. Then they can share this information with the fabricators, and then fabricators go ahead, if everything's okay, if everything's corrected and all requirements are met, fabricators can go ahead and produce whatever the designers want, and then this saves a lot of time. Then this offsite fabrication can then be shipped to the project when it's needed in the right amount of time. BIM is also used on on-site use through verification, guidance, and tracking of construction activities through the 3D models. So I'm sure you guys have seen people with their the tablets, and they keep checking through the 3D models so they can walk on the site and keep checking through the 3D models to make sure that everything's okay. And BIM can also be used for the implementation of lean construction. This is an example of a specialized drawing for different fabricators and installers. So this is pretty much what a designer would go to the fabricator, they would sit down and talk about what they want, and then the fabricator could go ahead, have the green light, and start fabricating what is needed. In post-construction, BIM can be used to hand over the facility information, such as the maintenance information, and the owner can then go ahead and everybody can check. There's systems that can be checked to make sure everything is running correctly, and then and then this information can then be handed to the owner. The source of managing operating information. So this is after the information is already handed to the owner. The owner can keep this BIM model and BIM information to make sure that it's running, it's managing and operating its building correctly. BIM can also be used in green building. This is through the use of energy analysis, which helps predict the energy cost and the building's energy consumption. This stored information can further help owners with the operation and maintenance of their green building to continue to improve overall building quality. This is a video, but the sound is not working. This is kind of like this video. It was a collaboration between AutoCAD and the U.S. Green Building Council to demonstrate the future of BIM technology related to LEED principles. And the conclusion, despite some obvious disadvantages, BIM has proved and has continued to grow to become a more efficient and effective means of the design and documentation process of a building. In summary, BIM is a database-driven representation of the building throughout the building's life cycle, which incorporates many tools and collaboration to improve the future of tomorrow.
Thank you.
Any questions?
Yes, any questions for Faith, please? All right.